Welcome to the first session of tutorials on force. We started the series of tutorials on statics, and the first set belonged to vectors because I believe that the first step must be taken with understanding of vectors. So if you have not watched the previous videos, I strongly recommend you to go and watch them because without understanding of vectors, you cannot have a profound understanding of the concepts in statics. So let's begin the second set of tutorials which belong to the most important parameter in statics, which is force. Like usual, I'm going to define this parameter. A simple and straightforward definition of force is here. Force is the action of a body on another. So force is the interaction among different bodies that cause the movement or deformation of the bodies. So imagine there is a box on the floor and a person tries to move the box. So this person exerts a force like F to move the box in this direction. And of course, the box has a resistance to stay or remain its initial position. If this person can overcome that resistance, that different parameters are included, like friction, like the mass of the box, and so on, the box will move along the direction of the force. Otherwise, his attempt is useless. Based on this simple example, first we have to go through the three Newton's laws which the classic physics orbits around them. So Newton's laws are very important because they are the principles of physics and mechanics. The first law states a body or a particle tends to remain at rest or keep its uniform velocity. So when that person tries to move the box forward, that box as a body tends to remain at rest. And that resistance origins from the first law of Newton. The second law of Newton states acceleration which is a vector quantity, and if you remember in the first tutorial of vectors I wrote it down and I said it's mostly studied in dynamics, but this is an important part of Newton's laws. Acceleration is proportional to the sum of force vectors. Basically, it can be written in this expression. So there is a relationship between acceleration and the sum of force vectors applied on the body which accelerates. And the third law states that every action on a body has a reaction with the same magnitude opposite direction and is collinear. Collinear means action and reaction forces lie on the same line. So with this in mind, we can focus on the concept of force. So as I said at the beginning of this tutorial, force is the interaction among various bodies that causes change in their position, shape, and motion. Force is a vector quantity because it has both magnitude and direction. When force is applied on a body, its action is defined by the magnitude, angle, and point of application. For example, here point A is the point on which this force has been applied, and of course the angle plays an important role in the definition of the process. Force is an external action. So basically, when a body is subjected to force, it's considered as an external action because another body, it can be the person's hand, it can be wind, it can be wave, everything in nature can be considered as the origin of the action of the force vector. So this action is considered external. So what are the internal actions? Internal actions are the resultant of the external action which cause the formation of the body, such as elasticity and plasticity, but those parameters are out of the scope of this tutorial. But we will study them separately under mechanics of materials. So mechanics of materials studies the internal action of bodies. Also, in statics, the bodies are assumed to be rigid. So you may have heard rigid bodies in different resources. Rigid body is a body that doesn't display deformation when gets subjected to external force. Therefore, a rigid body when is subjected to a force like F at the point A, so point A is considered as the point of application. But since the body is rigid, we can say it has the line of application along which the force remains its magnitude. So if this body is a rigid body, the amount of force exerted at the point A is equal to the amount of force exerted on the point B. So this line, this dashed line, is called the line of application. This is very important part of statics because we study the formation of bodies in mechanics of materials and dynamics. But in statics, we assume that the bodies are rigid. So the force vector in a rigid body is considered as a sliding vector. Which means that it remains its magnitude along the line of application. With this in mind, in the next tutorial, I will introduce the principle of transmissibility, which is an important concept in statics.